Good day everyone, welcome to .NET User Group Online for June. Today, I'm going to talk about how to get started with Azure Machine Learning Service. Machine learning is a blazing topic these days, although a lot of people might find it difficult to understand the concept of machine learning and hard to start their machine learning journey. However, with the help from Azure Machine Learning Service, it is actually quite easy to build and deploy your first machine learning solution. I'm going to show you how this is done in my today's presentation. My name is Patrick Zhao. I'm a senior software architect at SSW. You can find me on Twitter. I like to tweet about technology and sometimes my personal life, especially about my little one who's at his terrible 2 at the moment. If you want to be a little bit more formal, connect me via LinkedIn. In my spare time, I like to work on some personal projects and also contribute to open source community. Find me on GitHub. Every now and then, I enjoy writing blog posts as well to share the lessons I learned from working on my project. A little bit about myself. I have over 6 years of experience in fintech industry, during which I have delivered a number of data analytics, machine learning, and big data solutions for a variety of clients, including financial organizations, banks, gaming companies, and accounting firms. I'm keen on picking up new technology for machine learning, big data, and cloud computing, especially Azure. And if they can marry up, that's fantastic. And in today's talk, Azure ML Service is actually a great example that machine learning combines with cloud technology. Here is my today's agenda. First of all, I'd like to have a quick overview for the concept of machine learning, and then we'll move on to talk about deep learning, which is an enhancement of machine learning. And I'd also show you some famous deep learning frameworks and why deep learning frameworks are important for data scientists to deliver a deep learning or machine learning solution. Then we come to the core part of today's presentation. I'll show you Azure Machine Learning Service in detail, and I'll also explain why and how Azure Machine Learning Service solves some of the problems and potential challenges in a machine learning workflow. At last, I'll run a demo in which we will solve an image classification problem to recognize handwritten digits with the help from Azure Machine Learning Service. And we will use TensorFlow as our deep learning framework. Now, let's begin. When we talk about the concept of machine learning, it is actually about creation of a bunch of algorithms which can self-modify without much human intervention. So that when feed itself structured data, it can produce a desired output. On top of machine learning, we have the concept of deep learning. It's a step further that it's about constructing a layered network of algorithms which imitates human brain's neural network and imitates the human's thinking process. That way, it can reduce the error rate to maximum and have human impact from external at minimal level. When working on deep learning solution, usually data scientists and engineers like to use deep learning frameworks. There are a lot of reasons, but one of the most important reasons is that deep learning solution usually requires the ability to learn by itself, and also it needs a massive computing power and huge amount of data and the ability to handle this huge amount of data in a complex neural network. Imagine if data scientists and engineers need to craft out each individual algorithm present in the neural network nodes. Then it's a huge amount of effort and input in implementing each single deep learning neural network. So, as a result, data scientists and engineers would choose to use or leverage some deep learning frameworks. These deep learning frameworks usually offer a huge amount of APIs of algorithms for data scientists to pick and choose. That way, data scientists, engineers can focus on constructing the network of those algorithms instead of working out each individual algorithms separately. So the entire development process for this deep learning solution is much easier and quicker. I have listed some great machine learning frameworks that are popular these days. There's TensorFlow from Google, and TensorFlow is the most famous one these days because it offers a rich standard library of different APIs so that you have a big amount of algorithms to pick and choose from. And by the way, TensorFlow 2.0 was released last year, and now it has been used by a lot of companies already. There's a Cognitive Toolkit from Microsoft, which is popular among Microsoft and Azure developers. It's specialized in voice capturing, image cognitive service, especially handwritten digits recognition. You're welcome to have a look and give it a go. There's PyTorch, which is part of Python's ecosystem, so it's popular in Python user groups. And there's MXNet from Apache, which is a multi-language platform and frameworks. Now, when we talk about machine learning, thanks to years of experience contributed by data scientists and engineers, there's an established machine learning workflow that almost each individual machine learning solution can follow. And this workflow usually starts from data ingestion. We require this data ingestion process because machine learning usually requires a large amount of data to work with. And instead of worrying about fetching the data from different sources on the fly, we would prefer to have a separate data ingestion process so that within this process, we're going to screen data from different sources and put them to a static data set so that the subsequent machine learning process or operations can focus on working on the dedicated data sets. There's another main reasons why we need this process is that we need to be able to associate the datasets with the models we trained later down the track so that we know which model is trained from which datasets and which model suits which type of datasets so that we can decide which model we need to serve when we want to predict problems that belongs to certain datasets. After the ingestion process, we can start working on the features, which is essentially about transform the data to a shape that is clean and tidy for us to train the model. This feature engineering process not only trim out the dirty data, such as blank spaces and odd symbols, etc., but also it gives us a standard set of columns, essentially features, so that the algorithm can easily handle and train the model. Next, we can start training our model. The model training process is usually done by leveraging some deep learning frameworks, as I showed in the previous slides. And we usually would build and construct a layered neural networks and then feed the set of data we transformed before to a set of algorithms so that it will produce a model so that in future we can use the model to predict upcoming new data. All right, after we have trained the model, we can use the model for sure. But before that, there's an important step that is called model registration and versioning. Model registration is very important because there could be several different models we trained by running the training process again and again. However, in order to choose and pick the right model, we need to know which model belongs to which dataset. So, as I mentioned in the first step, we need to be able to associate a model with a certain dataset. And further down the track, we might want to fine-tune the hyperparameters so that one single dataset can train different models by feeding itself different sets of hyperparameters. As a result, we have to put a label on different model, and this registration process can later on help us to identify the model we trained. And also, the format and the pattern in the data may change, so that one single model may need to have different versions as time goes by, so that we know at which certain timestamp which model to pick and choose to predict different data sets. And at last, we can serve our model in different type of services, REST service, SOAP service, or Windows service, or any service we like, because we have the model registered in our model store already. I'd like to show you a diagram I have here that I grabbed from a Medium post by Microsoft. And the reason why I like it is because it illustrates the machine learning workflow very well. As you probably can see, there are 5 steps, as I covered in the previous slides, showing on this diagram. But what most was mentioning to me is that this workflow is in a circle. And the reason why it's in a circle is that most of the time, we need to rebuild and retrain the model. Here I have an example. Hackers may try to steal your credit card by having some anomaly pattern in the behavior, such as they would want to use your credit card in some different places than your normal places. And this anomaly pattern can be captured and detected by a machine learning process thanks to data scientists' hard work. However, in the meantime, data scientists or engineers have worked out a model to predict the anomaly pattern in the transactions. Hackers become smarter as well at the same time. So what they do is they will slightly change their behavior, but they can still try to hack your credit card. In that case, the model we trained before with the existing amount of transactions that we have might or might not suit future transactions, because hackers become more smarter and the anomaly pattern in presenting the data slightly vary from the previous ones. That way, we need a quick turnaround to update our model or completely rebuild our model to suit this new change in the data set that we use to train. That way, we have to have a closed circle of this workflow. And as we can see, after we deploy the service, we might need to retrain or completely rebuild the model. All right, as we can see, the machine learning workflow is quite complex. And this complexity brings in certain challenges and potential problems in delivering a machine learning solution. I have summarized those challenges as below. First of all, we need a good collaboration between engineering team and data scientist team. Usually, a machine learning solution team is composed of data engineers, data scientists, DevOps experts, and each individual might speak slightly different languages, and it's hard for them to understand each other. So, the collaboration is very important. Secondly, as I mentioned before, the pattern in the data changes, so that we need a quick turnaround to update or completely retrain, rebuild the model. And the scaling for the services we deploy from the model is also very important and challenging, especially for prediction in seasonal events such as Melbourne Cup Day or Black Friday, because on that certain day, the amount of transactions we need to predict would suddenly increase an enormous amount. And our services, especially our scoring prediction service, need to be able to scale up and out quickly. And at last, I put development standard as one of the main challenges. This might or might not be a problem for different teams. However, for the team who want to pursue best practices, it is very important for them to have a development standard among different team members, so that different team members can communicate to each other easily, and also it's easier to bring new team members on board. With these challenges, we might find it a little bit hard to start building a machine learning solution, especially in enterprise projects. However, Azure Machine Learning Service solves these problems very well. First of all, Azure Machine Learning Service is a one-stop workspace, so that different team members all work on a same portal in the same channel. That way, it will enforce team members to speak the same language, or at least they can speak the same terms. And this way, they will try to understand each other in the same terminology. Secondly, it offers rich integration with other Azure services for sure, but these services include services such as IoT, IoT Hub, IoT Center. This is very important if you need to stream your data and ingest your machine learning process from IoT devices. And then it has integration with big data, Azure Databricks, Azure HD Insights, etc. And it has integration with different storages, SQL storage, NoSQL storage, persistent storage, etc. And Azure ML Service supports a lot of open source frameworks and languages, including but not limited to the frameworks are listed in my previous slides, but also languages like Python and R and etc. All right. Azure Machine Learning Service also has DevOps built in mind. When Microsoft released Azure ML Service, it offers a complete methodology and process for automation in machine learning solution. And that way, if you need to rebuild and retrain your model to fulfill the entire workflow automatically, it is easier when you leverage Azure Machine Learning Service. And last but not least, Azure ML Service supports a lot of different tools. It has a dedicated studio, and also it is part of Azure Portal. Secondly, you can use Azure Machine Learning Service via CLI. So CLI groups, you're gonna like it. Last, that's my favorite. It has a very nice Visual Studio Code extension. So for me and for a lot of developers, we use Visual Studio Code every day as our default development tool. A nice Visual Studio Code extension for Azure ML Service make it easier for us to come on board and use Azure Machine Learning Service. All right, so with these features I listed before, Azure ML solves the challenges in machine learning workflow. I have them in a comparison in a table as shown below. So we have certain challenges in the machine learning workflow, and Azure ML has the solution for each one of them respectively. For instance, typical machine learning workflow requires a good collaboration in the development team, composed of different people from different backgrounds. Azure ML solves the problem by offering a one-stop workstation which enforces people to speak the same terminology. And in a typical machine learning workflow, we need quick turnaround. Azure ML Service offers rich ML ops features and functions to empower the process of automation so that we can have quick turnaround when we need to update or completely retrain the model. We require scaling in certain scenarios, especially seasonal events in a machine learning workflow. Azure ML Service solves the problem by offering different compute and service options so that you can decide how powerful the function, the machine you need to train your model, and how powerful your service need to be to serve the model. Most of the time, we want to implement and apply development standard because we want to have a more capable team, and also we want to bring new team members on board easily. Azure ML Service supports a lot of different languages and tools so that no matter what kind of standard you want to implement in your team, you have the options from Azure ML Service. All right, here's the end of the introduction of Azure ML Service. Next, I'm going to show you a demo to show Azure ML Service in practice. I came across this problem a couple of times that we sometimes need to recognize the handwritten digits, especially on forms or on letters that are of low resolution. And this is a famous problem that a lot of data scientists and engineers have when they started their career as well. So we're going to use a TensorFlow 1.15 as our development deep learning framework. We are going to build an image classifier to try to recognize and then classify these images. We're going to use a data set called MNIST. This dataset contains images that are kind of blurry and with low resolution. So in order to train them, we have to apply good feature processing process, and also we need to have a good machine learning model. All right, so we're going to classify those handwritten digits. I have an example of those images below. As we can see here, those images, each of them is a digit from 0 to 9. We'll try to recognize them, and so that we can predict them which image stand for which digits. The original code is on Microsoft document repository. You're most welcome to download a copy and play it in your own time or follow my demo. Now, let's begin. To start our demo, first of all, I'll show you how to create several services or the machine learning workspace that Azure ML offers. As I mentioned in my slide, Azure ML Service offers a one-stop workstation, and that is called Machine Learning Workspace. You can easily find it in Azure Marketplace, but I have already created one. So after we create it in your resource group, what we'll see is a machine learning service appeared here. If we click into it, what we can see is it organizes a bunch of assets. And this is special for machine learning workspace that you will not see in other Azure services. As I showed in the slides, machine learning workflow is a closed circle. And in that circle, we start from data engineering, and then we do model training. And this model training process is actually running some training scripts as experiments. But in order to run this experiment, we need to have a certain environment, and in Azure ML, we call compute. We can instantiate different compute with different specifications, like different computing power, like how much RAM or how many cores of the machine you need. And then after that, after we run the experiment, we will register the model so that we can serve the model images as different type of services that's organized in the deployment process. Okay, before we dive into each one of these assets, what I want to show you is on the overview page of your machine learning workspace, we can see a link to launch a tool called Azure Machine Learning Studio. After we click Launch Now, it will navigate us to a different URL, ml.azure.com, and this is the dedicated Azure ML Studio that I mentioned before. I like this ML Studio, and I prefer this over Azure Portal because, first of all, it's a dedicated place that all of our machine learning components can exist. But also, when we working on the machine learning solution, this dedicated studio offers us more features than Azure Portal. Okay, so as we can see, the assets is similar to Azure Portal, but it has a more specialized terminologies such as endpoint versus deployment. Because endpoint makes more sense because usually we want to deploy our model as different REST services that are conveyed by an endpoint. Okay, so after we have a quick look on Azure Machine Learning Studio, I'd like to show you my favorite tool in Visual Studio Code. Now let's go to Visual Studio Code. Now we are in Visual Studio Code. Before I show you any code or any thing related to our problem, I'd like to show you the Azure extension. Now let's just close this script for now, so that we can focus on the extension. So Azure Machine Learning is part of the Azure extension, as similar to app service extension, functions extension, and storage extension, etc. But it is special that, as we can see, we have the machine learning workspace, and different components in that workspace is organized underneath it. So this way, you can choose to either work on Visual Studio Code if you have your Visual Studio Code as your default code editor, or you can choose to work on the UI I showed you before. They are consistent to each other. Now, before I show you any of these features in detail, let's jump back to the code, and then I'll explain to you what we are doing today. As I said, we are trying to classify handwritten digits, but what those handwritten digits look like actually? I showed you an example in the slide, but here I'd also like to show you a real example of those images. So I have a short Python script where we import the data sets from minis package, and we just grab a random one of them. I put 9, we can just put anything here. Let's just go to 5th of the data set. And then I'll plot the image and show it so that you can look like what they look like. You can see what they look like in a grayscale. Now let's just run the script. Run Python file in terminal. By the way, I'm printing out something that we can use later, which I'll show you shortly. Now, as we can see, the image look like this. It's kind of blurry because it's just 28 pixel multiplied by 28 pixel. As we probably can tell, it's a number 2. So we are going to feed a huge amount of these kind of digits into a set of neural networks we're gonna build shortly, and the model we train will be able to predict which digits this image stands for later down the track. Okay, before we start the training process, I should just quickly show you another image, so that you are convinced that these images look blurry. So let's just pick another random one, the 18th of them, and we run it again. All right, as you can see, yeah, we can probably tell it's 6, but it's kind of blurry and of very low resolution. So in the entire dataset, there are hundreds of thousands of images like this. We're going to use this to train. Okay, next, I'll show you the training script. So the training script starts from grabbing the data from the data set. So we have the data preparation process. Let's just make this smaller, and we would jump into this implementation of this prepare data method. As we can see, we download the data, and then we load the data and separate them to the training set and the test set. And after that, what we do is back in the training script, we have some hyperparameters specified here. And in the real machine learning solution, these hyperparameters can be parameterized so that a configuration can change for different training process. And this can all be done in the Azure ML pipeline. Now, in the main body of the training process, I have several layers of my neural network. And we instantiate a training session from TensorFlow, and we will just run through the training process by feeding the data to the layer network as different epochs. So that way, we can train the model and get a frozen model. And at the bottom, we save the model to a directory next to this training script. Okay, so this is a typical TensorFlow training process. But what's special about this demo is that here we have a login process offered by the run instance, and this run comes from getML run. So if we go into the implementation of this, what we can see is that we are getting a run from the submitted run. And this is all offered by Azure ML package. So what this means is we'll submit the training script as a run to an experiment to Azure ML service. And in that run, we can do all sorts of different things. What we do in my demo is we log different metrics, like the validation accuracy and training accuracy. You can log other things as well. By logging these metrics, we can see the run being executed live on the Azure ML Studio. I'll show you how it looks like later. All right, I have showed you the training script. We understand how we want to train the model. Next, what we will do is we'll actually run this training script. So what we'll do is we'll jump back to the Azure ML service extension, and in the experiment tab, we right-click on it, and we can create an experiment there. So we just need to follow the wizard so that we can create our experiment. So an experiment 4 is created. If we expand the experiment tab, what we can see is, let's just let it load. So we just created experiment 4, and what it does is the extension will submit a request to Azure ML service to actually create the experiment for us. So that's why it's thinking, because it's creating a new experiment. And experiments is actually just a logic group of your different model training run process. Because, as I mentioned, you might need to run the same training script with slightly different helper parameters to suit different data sets to be able to capture different patterns in the data. That's why we need to organize your training script runs into different experiments. It's still thinking, let's just refresh it. It looks stuck. Let's just close Visual Studio Code and restart it. Now let's go back here and see if it refreshes. Now it loads. As we can see, we just created experiment 4, and I have other experiments created earlier as well. So what we need to do is we can set experiment 4 as the active experiment, and we can actually run the experiment. And once we have decided to run some experiment, wizard would prompt up and we need to follow it. Do we want to switch the active experiment? Yes, we want to switch. Now, as the prompt window showed us, we have to choose or create an ML compute. Now, I'd like to explain to you what is an Azure ML compute. So basically, Azure ML service offers two types of compute. One is called compute clusters, the other is called compute instance. So in compute clusters, it's actually just different environments or virtual environments that you can have different specifications of the machine with different RAM, different number of cores, so on and so forth, for you to provision and run your experiment. And that those compute nodes in the cluster can be scaled up and out and also down or in quickly by few clicks if you need. Okay, you might have some existing virtual machines or compute resources on Azure already. You use them to run your other services, like you have a virtual machine to serve your website, but you want to leverage that virtual machine computing power in the off-peak time. You can do so by attaching that virtual machine as a compute instance here. But now, we have created a cluster beforehand, you can easily do so as well. You just right-click on it and create compute, and follow the wizard. So now we have created Azure ML compute before. We're just gonna choose it. Now, next step, we need to create a run configuration. A run needs its specific configuration because different run of the same training process may have different dependencies, because you may have different hyperparameters. You might use a slight different variation of the algorithms or the neural networks. I have created a run configuration before, which I can show you later. So we're just gonna create it. Okay, we selected the run configuration, and then we create an experiment run, and we have submitted to Azure ML. We can actually view the experiment run by clicking this button, and then this dialog would bring us to Azure ML service. So on Azure ML Machine Learning Studio, we can easily see the machine learning run that's been submitted and queued. So let's just leave it being queued for now, and then we'll come back to view it a bit later. Before that, as I said, I'll show you the run configuration. So all the run configurations would be created underneath the AML config folder, and the one I created before looked like this. Just close this and make it full screen. So as we can see, this run configuration is actually a series of metadata. We see where is the training script, and what is the framework, and what are the dependencies, and where the dependencies install from. We install from pip, and more importantly, it has definition for the Docker image, so that we can specify which base Docker image we want to use. And absolutely, Azure ML offers a lot of different default base images for us to use. So, and also you have your specification for your Spark big data platform and your history configuration. So, having the metadata in a run config means that we can save this file and use this file to automate the creation of different experiment runs later down the track, so that this process can be automated easily when we need to. That is the biggest feature of Azure ML Service, ML Ops, or Machine Learning DevOps in mind. Now let's just jump back to Azure ML Studio and have a look at our experiment run. So we have experiment 4, and we triggered a run. It's been queued. If we go back to the experiment tab, we can see that previously I have experiment 1, and underneath experiment 1, I have 6 runs. So on this overview page of my experiment 1, we can see that it has a summary of those runs: 6 completed, 0 running, etc. And we can see the training accuracies that we logged in our code on an aggregated view, and we can tick and untick so that we can focus on the runs we need to focus, so that we can clearly see a comparison of different runs when the iterations goes on. What is the training accuracy? And this way we can compare different runs easily, so that we can make a decision, or at least a justification of the quality of the model as an end result. And the same as validation accuracy. And on this summary view, we can see the different statistics about our run. What are their status, when they were submitted, how much time they took to run, and who submitted them, and which compute target they run on, and etc. Okay, let's have a look at our new experiment 4 and see. All right, so our newly submitted run for experiment 4 is running now. Let's click into it and see how it goes. So when we click into a run, what we can see is that first of all, we can see an overview of the details of my run. The same sort of statistics that we saw before. This is good for auditing process because we know almost every piece of information we need according to the ones we specified in our model run config. But what's more interesting is these images and matrix tab. It's still running, so there are currently no matrix. Let's just bear with it. But the output and logs are also very important and interesting. So what we can see is that there's an execution history of this model run. And as we see, the whole process of how Azure ML service trigger this run is very clear here. It's pull an image to instantiate an image environment, and then it will download the image and instantiate it and launch it. Let's just wait for it and see how it goes. So while we have already submitted it and it's still start to run, I'd like to show you this result of an existing run. So let's just pick run, say run 5 from my last experiment. So what we can see is we can see the detailed matrix of this one. So make it a bit smaller, so they will be side by side. And the output it generates, as I show you in the code, we in the end freeze the model in a folder next to our training script. So these are essentially put alongside the logs for the training process and Azure ML general logs. So let's just have a quick look at the logs. There are all sorts of different logs that we can have for the run specifically and how it is run, as we can see. The training process is triggered by Azure ML compute target, and the scripts are run accordingly. And also, we have the Azure ML logs, which is the log from the environment. So as we can see, when we run the experiment, it lists the training accuracy and the validation accuracy as the logic we implement in our code. And this is the model. For our demo, we freeze the model in checkpoint format, but you can freeze it in all sorts of different formats if you need, like H5 format, for Keras, and so on and so forth. Okay, let's have a look at our experiment 4 and run 1 and see if we generate a matrix for us. As we see, so the matrix comes up. Let's make it bit bigger. And we take training accuracy and run validation accuracy. As we can see, it's now currently running to, actually we need it smaller so that it's side by side. It's running to epochs 42, and the current training accuracy reaches 1. The validation accuracy reaches 97.99. Okay, if we refresh, I can refresh here. Now it's running to epoch 60. Okay, so this is actually live and ongoing. So this feature is very nice because it helps development team to monitor and judge their model on the go. Imagine we are running a very long training process, which potentially has a layer network of 1,000 layers, taking in amount of data worth of 10 gigabytes. Then the training process would take hours or even days to run. And for implementation or experiment purpose, if we have to wait till the end of a training process to tell whether we are happy or satisfied with the training accuracy or validation accuracy, that's taking too much time. So Azure ML service offers this live matrix feature so that when the training is going on, we're able to tell the current training accuracy and validation accuracy. If we see something abnormal here, we can decide to stop this training run, and we can fix in our training script, and we submit another run. And this empowers the collaboration between different team members as well, because different team members can all watch the model run through the same portal. And for instance, my colleague can remind me, say, hey, Patrick, I see the model run you triggered a moment ago has some obvious defect in it. Can you please pause it or stop it, and let's fine-tune your model together. And this way, we collaborate more effectively and efficiently. All right, we'll just leave the model run here for now. And we can jump back to Visual Studio Code. Now, after we have submitted the model training as runs, and it will run and freeze the model somewhere, next step is that we can actually register a model when we need to. So in order to register the model, we can actually do that via either Visual Studio Code extension or on portal. So in Visual Studio Code extension, if we right-click on model and we click register model, we can follow the prompt and finish the model registration process. And also, everything I show in Visual Studio Code extension can be automated in code, so that we can register this model after we freeze the model as well. Let's just go back to Studio, and let's register model from here, just to show you that we can do it via UI as well. When we click on the register model button, we'll give it a name, just sample model. We can give it a description, it's optional, and then we choose the framework here. Let's just choose TensorFlow version 1.15, and we can upload the model file. Actually, the model we froze is in checkpoint format, which is actually a folder. Actually, let me show you how the folder looks like. So we go back to our output folder. Just review in File Explorer, so that the model we froze look like this. So it has a checkpoint and the TensorFlow's index meta data. Now, come back to portal. We can browse this, and we can actually upload it. Okay, now after we hit register, a new model will be registered, and you have the version number here. That way, we can run versioning on our model. Now, if we come back to code, ML extension, and we hit refresh, and we expand models, we can see the model we created on portal appeared here. And it has the version tag appended to it. If you right-click on it, actually I'll right-click on one of the model I created earlier and view the model property, just to show you what a model looks like. So we give the model a name and ID, and we have all sorts of different configurations for the model. So this way, we can easily audit the model we created, so that we can decide whether it's a good one or not, and we know which dataset is associated to. So once we have the model, we can deploy the model. To deploy the model, we can do it either here by deploying an endpoint. We just right-click on the model, and we can deploy service from register model and follow the prompt. As we see, Azure ML Service Visual Code extension by default offers ACI as well as AKS. But if you want to deploy the model in the other services you prefer, such as Azure Function, you can do so as well. It's just you cannot do it out of box from Visual Code extension. But you can also find the model and locate the model in the model registration, in the model registry, and serve it from there. Because all the model images are there in the model registry, you can reference it easily as well. Let's just go back to Studio, and let's have a look at the models. If we click this model, we can deploy endpoint from here as well. I have already got several endpoints deployed earlier, but I'll deploy a new one. So let's just give it a name called VC test 3, and we'll deploy as ACI. Yeah, we can have authentication as well, but I'll just disable it for my demo. Now, we have to supply a entry script for the prediction process, as well as a Anaconda dependency file. I'll just put them here for now, and then I'll explain to you briefly. So we have a score script as well as a environment YAML file. There are some advanced options that you can enable SSL, and you can have a reserve capacity for your container instance and etc. So everything can be configured and automated, scale up and down easily. So let's just hit deploy to deploy our model. All right, so now a model deployment has been submitted. Before I explain to you what I supplied as training and running script, what I want to show you is in the Visual Studio Code extension. Let's just collapse everything and refresh here. Let's just exit this. And in the endpoint, we can see a new endpoint has been created here. So again, everything you do on the UI, the Azure ML Studio, can be done, or most of them can be done in the Azure Visual Code extension, and they are interchangeable. This way, you can have your own choice of your preference. Now, I'll just quickly explain to you what I supplied as the service dependencies. First of all, we supplied a scoring script. So what it does is actually, let's make it bigger. It offers two methods for us to implement. One is init, the other is run. In the init method, we import several dependencies from different packages. And the most important one we import is the model from Azure ML core package. And in the model, we can get a model path by giving it the model name we registered earlier. And then we just instantiate TensorFlow session by loading the TensorFlow metadata, and then we identify the tensor, which is the node in the neural network. and we just leave the session open from there. And then we can reuse the session to predict or to evaluate our upcoming data. And that data is loaded from the HTTP request data session. So this way, you can decide whether your TensorFlow session is scoped or transient or singleton based on your need. And for some other deep learning frameworks you use, if they are limited to transient, then you can have your all your logic inside the wrong method, which gives you options. After we had a look at the scoring script, let's have a look at the dependency script. It's a YAML file essentially, and in it we can specify our dependencies. But note, these dependencies are for our scoring scripts, not the training scripts we showed earlier. So this scoring script may have slightly different dependencies other than your training script. You only need smaller amount of dependencies to run your model than training your model. And sometimes when you get a model from others, the already trained model from others, all you need to know is the dependencies that you need to run the model. You don't want to retrain it again. All right, so I have shown you the model deployment process. Let's just have a look at how our model deployment runs. We can see the endpoint status in Azure Machine Learning Studio. There's no problem with it. We can see the model we just created is up, but it's still in transitioning status. Okay. Instead of viewing it here, my personal preference is to view it on Azure Portal. Let's just come back to Azure Portal. So underneath our resource group, what we can see is a new service has been created. It's a normal container instance, no different from other Azure container instance you worked on before. So if you click on it, what you can see is it's currently running, in which stage, and you can see the logs of it, how it's been launched and run. Okay, so let's come back to an existing service I created earlier. So we supply the URL, and it's in running status, and everything is up and running. So now let's test it. In order to test it, so what we do is very simple. Just on the HTTP client tools of your preference. For me, I use Postman. We need to copy the URL of the Azure Container Instance and paste it to the endpoint here, and we do /score. That's by convention, and we can then post a body of the data so that it can predict for us. As I mentioned before, those images are 28 multiplied by 28 pixels, which in result is 784 elements in the array. So what we did as part of the training process is, let's just get one step back and have a look at how we prepare the data. So when we prepare it, we will, let's make it bigger. We will reshape it to a one-dimensional array, and we divide by 255. So we repeat this process when we try to predict the data. In my script I showed you earlier, we not only display the image, but we also reshape the data to a 784 elements, and also we divide by 255 so that the data we use for prediction is the same one as we used for training. So let's just run this again. So this time let's just use a random sample, and we run it. So once we run it, we can see there's an image showing up, but also I have my data output here. This is this image in a flattened way. So we copy this and we paste into Postman. So let's just remove what I had before and we paste it here. Beautify. So as we can see, there are 787 rows, well actually 784 elements in the data field. Remember, in our scoring script, we grab the data from the upcoming requests data field. Now, we have our data ready. Let's hit send. It's recognized as 4. So our model is quite smart. It can recognize a blurry digits. Let's just run another one to convince ourselves that our model works. So let's just have another sample as an index. Let's just a random one. Okay, let's run this again. Run Python file in terminal. Just see it runs. Okay, so now we have another image show up. Let's see if we can predict this image properly. To me, it's a 9, but let's see if it will predict it as 6 or not. Let's just copy this request. My mouse is not working. Now it works. Okay, let's just copy it and paste in our request body. Beautify it. Yeah, we have another 784 decimal numbers, and see if our service can predict it properly. Oh, it's recognized as 9. Hooray! Our model works. As a summary of my presentation, first of all, we went through machine learning, and I've had introduced some deep learning frameworks to you. And then we discussed about Azure Machine Learning Service in a bit of details. And I also showed you how Azure Machine Learning Service solves some of the typical problems and challenges in a machine learning workflow. I also showed you a demo using Visual Studio Code Azure Machine Learning Service extension. We use TensorFlow to build and deploy a handwritten digit image classification solution. And our solution can properly recognize handwritten digits from kind of blurry image, so which is a great success. And as you see, it is actually quite easy to build your first Azure Machine Learning Service solution easily. My name is Patrick Zhao. You can find me on these social media links. And if you want to play with yourself, I have uploaded the code. I showed him a demo to my GitHub. And don't forget to scan the QR code below on SSW Rewards app and earn 500 SSW points for watching this talk. I'm Patrick Zhao. See you next time. Bye.